Next up, we have the amazing J.R. Oakes. He is the technical SEO researcher at Locomotive, and he's going to be going through how to build a simple search engine and rendering service and teaching you guys how that works. Take it off, J.R.
Thanks. How are y'all? So I like building things, so I thought it was a pretty interesting idea to try to build a toy internet and a toy crawler. I set off about a month ago, so this should be interesting. About me, as Paul said, I'm the Director of Technical SEO Research at Locomotive. I'm really passionate about development, learning, community. We do a lot of meetups around the Raleigh area. There's a lot of Raleigh people represented here. Awesome. I love Twitter. I do try to share as much as I can on GitHub, so if you're interested, my GitHub is JR Oakes, just like my Twitter handle, and I try to put as much stuff up there as possible, just fun to play with. And work for a brilliant team at Locomotive who used to be called Adapt. We recently rebranded. All right, so what we will learn. Overview of the crawling landscape, key components of a crawler. We're going to go through building a toy internet that we can crawl, and then building a simple crawler and renderer. It shouldn't be unknown that I'm a big Python fan, so most of all this will be in Python. So the web is huge. We've worked with clients that have, I think, up to 1 billion web pages, of which only a portion of those are crawled. When we're talking about the landscape for crawlers, it's segmented into URLs crawled, the URL frontier, which is what they want to crawl, and then unseen URLs, or URLs that may not want to be seen. There's a lot of depth and junk on the internet that we may not want to spend time crawling. This is hypothetical for me, but I think PageRank, because it is a popularity metric for URLs, and the popular page linking to another popular page, the inverse may be true, which is if it's a very unpopular page, right, we may not want to follow the links on that page. So that may be a mechanism to help us keep the crawlers from going too deep into the web, into rabbit holes that they don't need to go into. Google has an inverted index of 25 billion URLs, which is just mind-numbing to me, and less than a second response time for that. An inverted index is essentially if you're doing a search on a bunch of documents instead of going document by document and looking for a keyword in each of the documents, you essentially process the documents first, where you're searching on words that are mapped to documents. So instead of going through the individual documents, you're looking for the words that are then mapped to the individual documents that are returned. So in going through thinking about how I would construct a crawler that would crawl my simple internet, I needed to understand the basics of what a crawler has to do. So it has to be robust, handle spider traps and malicious behavior. It has to be distributed in that it has to run across multiple machines, have many microservices that it works with. It has to be scalable in that they have to add additional machines without it stopping the crawl. It has to be efficient and use network and processing resources wisely. Prioritize, it has to know the quality and the priority of the pages that it's going to crawl. Operate continuously, be adaptable, which that's the coolest thing for me, is that Google changes so much, like so many times a year, and is incorporating so many new technologies like BERT, et cetera, into their search results. And having this massive infrastructure of crawlers that they're able to just change whenever they need to get additional data is pretty mind-numbing to me, especially within the number of URLs that they crawl. It also has to be a good citizen, which is respecting servers and respecting robots, et cetera. So this is from key components of a crawler. This is from Chris Manning and Pandu Nayak, which are professors at Stanford, which just lays out, can I get a water? Which just lays out the overall layout of a crawling process from left to right. Thanks. So you have the internet, you have fetching, you have DNS, which is all cached, because DNS, obviously they're not going to do DNS lookups for every time they want to render a new page. It's fetched, it's parsed, it goes through a process called document fingerprints, which is the deduplication that Martin was talking about earlier, where it creates things, it's called shingling, where it creates these min hashes of documents that it can store, and it can compare new documents that it comes into to see if it's duplicate or not. I don't know how many of you guys have seen the React sites that are, or Angular sites that weren't pre-rendered for a while, and then you would actually like do a site search for one URL and some other site would come up. It was because it was looking at just the raw HTML and then going ahead and making that comparison and saying this is a duplication of this other site, which I think is fixed now. But that's the min hashing, looking through and comparing and saying this is an exact duplicate of this before, and that took place before they actually did the rendering to find the full content. But I think that's changed now. This was something that was new to me. You tend to think of crawling and like a visitor coming to your house and starting at your front door and going through. But the robot's filters are actually handled as a post-processing stage before they even go into what's called the URL frontier, which is the queue of new URLs that they want to crawl. And then duplicate elimination. Is this something that's already in the frontier? Is this something that we've already crawled before? Is this something we've already crawled before and don't want to crawl anymore? So this is all filtered through here. This is what was interesting, because obviously I was freaked out last week coming on after Martin. And I was actually guessing like what a web rendering service could be like. So my thoughts were that we know that the HTML is crawled and then passed to the web rendering service. We know they have to do cache prior to, or aggressive caching on everything. We know that they want to extract the parsed DOM and do something with that. And then we know that, or we can infer that they want to take what they crawled, right, and then what they rendered and compare that somehow, right, and say, is there additional information here? Is there new stuff with this, right? And then if there's not new stuff, then maybe that prioritizes pages to be rendered less. If there is a lot of new stuff in the rendered DOM, maybe that prioritizes pages to be rendered more. It's hard for me, at least. I mean, I don't know like what Google wants to do, but this is a like 30-something-year-old site that hasn't changed and is never going to have JavaScript. So it's hard for me to believe that they would spend the resources rendering this. But I don't know. I'll ask Martin that later. So, I mean, key learnings from just understanding kind of the crawling landscape and a simple crawling pipeline is that the frontier, which is the URLs that they want to crawl, is broken into two sections, what's called a front queue that manages the priority of URLs, the quality of URLs that they want to crawl, and then the back queue, which essentially makes sure that they don't beat your site to death, right? And then they're respecting robots, they're respecting your crawl and not hitting it and having major 500 errors all over the place. All queues are first in, first out. Each host has its own back queue, which is kind of cool that your site has its own little special niche host of politeness on Google. Min hashes, or called sketches, are an effective way of deduplicating content. And duplicates and very near duplicates can be measured by a function called Jacquard similarity, which is just an edit distance. Everything is cached to reduce latency, even the DNS and JS and CSS. URL normalization is handled at the parser, which was something I didn't know going into it, that you actually have to change all these rooted URLs to actually full URLs to be able for Google to be able to cache those and handle them. And another interesting thing for me is that just thinking about like the possibilities of what can actually happen in the DOM versus just getting a raw piece of HTML and doing something with that. Which, I mean, if Google wanted to, they could just click on all the links, right? And say, what does that do to the DOM? How does that change things? All right, so first step in this is that if I want to build a renderer and a crawler, I have to give it something to render and crawl. And obviously, I'm not going to build something at the scale of Google. So I wanted to build something that is just, in machine learning, you do toy data sets, right? You build everything first on a little toy data set before you give it like massive amounts of data, just because it's easier to work with, it's easier to train. So the criteria for me was build quickly with topically similar pages for each site, exist on separate domains, they had to be linked to each other, and they have to contain basic SEO elements like title, description, canonical, whatever that you'd expect from a crawler. So you can see this on the right here is a bit of Python code that I wrote that essentially takes in 3 topics, scrapes Wikipedia for each of those topics and related topics, pulls the content from that, cleans the content from that, and actually builds out GitHub pages using their Jekyll rendering engine, Wikipedia and Python. So this is a notebook or a repo that I'm going to release after this that you can actually go in and run these things and build your own little toy internet, or you can use the one that I've already built for this deck. But you can see here by entering 3 topics and 3 organizations from GitHub that you create, you can create a very simple small internet. They're only linked to each other, and it gives you enough just to play around with. And yeah, and it's my PBN Maker 3000. And this is what they look like. Not much, but different topics, different information, different themes, and it's really cool to see the results. All right, so obviously everything that I talked about before with the scale and the robustness is not something that I'm going to build in a simple Python repo. So I had to really scale things down and make some accommodations with time constraints while being as accurate as I can to what is known that Google does. So the first thing I did was just did a ton of research. I spent a lot of time on GitHub just going through repos, seeing how other people did stuff, taking ideas. So I did a lot of research on GitHub. I didn't want to reinvent the wheel. I don't want to spend time making something that's already does something really well. So these are, I mean, if you're interested in Python at all for technical SEO, like these are some baller libraries here that you have that do incredible stuff. But I went through and you have a hashing library, you have NLTK, which is what Paul talked about, which is just cool as hell. You have Pandas, which is like spreadsheets that you can parse 1 million rows on Python. Puppeteer, which is just a port of Puppeteer for Python, which is really cool. Gensum, Goose is a great article extractor. Transformers has an easily accessible BERT library that every SEO can play with. As well as, Repi, I didn't even know Moz had their own robots.txt parser that was open source. So I gave them a shout out on Twitter. That was kind of cool. Step 3, a lot of coffee. It took about a month to do this thing and some beer. One other thing is, have anybody heard of Streamlit here? This is the coolest library. Like you can write any Python code and add Streamlit and just do write out statements, and it will produce like a visual UI for you that shows code, shows graphs, shows data, shows tables, allows users to interact with it and do slides and whatnot. It's incredible and super easy. So if y'all do any kind of data sharing internally or sharing of notebooks, Streamlit might be a pretty cool option for you guys. For the crawler and renderer, these were my criteria for what I needed to do to feel like I did enough to make it something that was usable for others, which is use existing libraries where possible, be hardy enough to crawl 30 pages, which wasn't hard. I wanted to make it as simple as approachable as possible, so I opted for libraries that weren't really difficult. Pandas is a really approachable library for people that are new to Python. I tried to be as true as possible to what I thought or knew Google did. I had to process linearly in that we didn't have any multi-threading or didn't depend on any external services, so it was easy for people to get up to speed on. I did a little bit of unit testing, so developers should be a little happy for me, because I never do that. And then I included a Jupyter notebook that you can go through and actually easily access some of the functions. And then I included a little simple indexer after talking with John Mueller on Twitter. He said it would be cool to have it so you could play around with it. So the parts of the crawler and renderer that I built include PageRank calculations, Chrome headless rendering. Per the talk earlier, or Paul's talk, there's an entire text NLP pipeline that you can it's normalized corpus, right? You give it a list of strings and it does the lematization, it does the part of speech tagging, it does everything and gives you like really clean text out. We incorporated BERT embeddings, which is kind of cool. Robots, duplicate content shingling, which is the min hashes I talked about earlier that compare duplicate content. I did URL hashing just because I thought that was the right thing to do. And then I included 2 document frequency functions, which is BM25 and term frequency. The big things with BM25 and term frequency is that BM25 is very similar to term frequency, but it takes into account the actual length of the page, whereby if you have a rare word on a short page, versus a rare word on a really long page that's across a lot of different topics, the shorter page is probably going to win out. So overall learnings from building this repo. So when you crawl the page and you get all of the minimum hashes for each of those, and then you can compare them and say, okay, I have 3 documents that are the same, right? I just applied PageRank and said, okay, out of these 3 documents that are really similar, which one has the highest PageRank, right? And I just picked that one, right? Made the other 2 duplicate. Deciding where to process and when to update values is really hard. Like, I can't imagine doing it at Google scale. And Martin was talking about all the different microservices that were talking to each other and going back and forth. Like, figuring all that out just is mind-numbing to me. Like canonical tags for crawling and consolidation in HTML versus rendered. Like canonical tags can be in so many different places, even in the header response, and it can be different from crawling to rendering. And like, where do you take that, and what do you take the authority of that, and how does that apply to links that you have to crawl? How does that apply to the page rank? It's very complicated. Index compression, if anybody reads through any of the resources on here, especially for the information retrieval stuff, I know Don Anderson does a lot of that. Like, that stuff makes my eyes glaze over. Like, I'll read it and read it and read it, and it's pretty deep stuff. One other thing that I thought was really cool about this is that, like, again, Paul was talking about in his NLP talk about tokenization and removing stop words, right? Well, like, BERT actually needs stop words, right? Because BERT can read the sentence, and if you take out the stop words, you take out a lot of the contextual information that's needed to actually understand what that sentence is trying to say. So that was a learning that I didn't expect coming into this. BERT is really easily accessible. There's a library called Transformers. It used to be called PyTorch Transformers, but like, you have every model on there. Like, everything you read about on Twitter, and like, hey, there's Alberta, there's BERT2, there's Distilbert, there's Control, whatever. Like, it's there, right? Like, you can like load it. It's a company, Hugging Face, controls the repo, but like, they have all of Google's models on there. They have all of Facebook's models. Just download them and you can run them. And you can see here, again, Paul touched on embeddings, word embeddings. You have to take the last hidden state. Like, you can give it some text. You take the last hidden state, and that's the embedded representation of that content that you just sent them. And then with those, you can compare and do similarity, and you can actually plot them, which is kind of fun to do. Also made some things way simpler than they would be in real life. And I'm going to give a nod to Russ Jones, because he's the one that mentioned this to me a few years ago. That, essentially I just have a box of content, right? Like, I just scrape the page, pull the content, stick it in a box. And like, for the titles, I did a title boost, which is just like, include the title 4 times, or 3 times, or 2 times, or 1 time, right? To make the words in that title either more rank or do better from a term frequency standpoint or not. The other thing is all the link anchor text. I just took the anchor text and just stuck it in the page, right? So if you're linking from and that's the one that Russ told me. If you're linking, and you've seen that, if you link to a page, it now becomes relevant for the anchor text that you're linking to it from, right? So it's essentially just taking the text, slapping it in the page, and then doing your processing on that. All right. There's one thing in at least NLP and NLG right now that doesn't get talked about a lot is like sentence piece and byte part encoding, which allows us, to have models that have like 30,000 tokens instead of several 100,000 words that you have to train on. That's part of, I just threw that in there, but I thought that doesn't get enough play in all the BERT and everything, but that's one of those pivotal pieces of NLG right now. Next thing was a minor code change can make the crawler go crazy. Again, I don't see how, there we have like a lot of crawler vendors here and tools here. It would drive me crazy to have to do that. Min-hash comparison made checking rendering to the crawled version really easy because you just get the rendered version, get to the text, or get the crawled version, get the text, render it, get the rendered version, get the text, min-hash, compare, is there more, is there less, and then that can tell you which one to grab. So the result is this TechSEO crawler that I'm releasing open source for everybody to play with. A few caveats that it was written in a month. Martin and all the Google engineers would laugh at it, and rightly so. It more than likely has bugs. But it's really fun to play with, and it has a lot of cool libraries. Like even if you didn't want to like build a little toy internet and crawl it, some of the libraries in there are good for I think every SEO who's interested in Python to start playing around with. And a lot of them are things that I've used and built into my repos over the years. This is the cool thing. This is Streamlit. And we have instructions in the README for this that you can download. And then you essentially run Streamlit, run main.py, and then it launches this in a browser. So it'll go through and do the crawling, it'll do the rendering, it'll do the indexing. It actually loads BERT vectors or BERT embeddings. And looks like this, where you can play with how much weight to give to term similarity, how much weight to give to PageRank, how much weight to give to BERT, which is cool. And then we have the two different term frequency types that's driven by the inverted indexes. And you can go in there and put in queries. It's not great, it's 30 pages, 30, 40 pages. But you can see here I searched for search marketing journalist, and then Danny Sullivan comes up at the top there. And we added an ad for Locomotive, which is kind of cool. That's it. There's a URL. This is Jake. Where's Jake? He told me to put this URL in here where I had the Cole crawler render indexer caboose. So that gets you to the repo and should be online. And if you have any questions, please let me know. And if you want to add to it, fix anything, please let me know. I think it could be a cool toy to play around with for the SEO community.
Awesome.
Yep.
We're going to do, JR, if you're good with questions, we'll do a few audience questions.
Okay.
Right? Guys, questions for JR, hands up. We have questions for JR. If not, you're sticking around?
Yes.
Yes. Anyone? No takers? Oh.
I know you obviously had a fairly small sample with your toy internet. I was curious with your crawler if you played with any of the ideas, if that most people don't build pages perfectly. So like one of the things I imagine is most complex for Google is trying to fix the things that are broken, like the canonical tags being different all over the place, but things like title tags not working, malformed HTML. Did you do any experimenting with just like where in that process they may try to fix all of that stuff?
Where
In the process of indexing, like crawling and indexing and parsing, like where they have to actually fix webmasters who break things.
The only thing that I did where I had to fix stuff, which is where I had to go in and via regex, when I'm extracting the content, I had to go through and make sure that all the URLs were absolute. So that was one fix, because if you're taking it from there and sending it to the crawler, or the renderer, which essentially you're just throwing open a browser page and then injecting HTML in there and asking it to render it. Like, it's not looking for local URLs, so you actually have to change those beforehand. So there were, and that does, and with the canonicals, that was the same way, right? Because some sites have relative canonicals, right? And you have to change those. So there was a little bit of that, but not a ton.
Cool. Thank you.
Yep.
Awesome. Let's give JR another hand. Thank you so much.